Hello, everybody. Good morning, good afternoon, good evening. Uh, Welcome to my lecture on of the database, and we do data modeling using ERD. The importance for it or the need for it is that first of all, a data model is. Let me first. Do we have something? So this is an example of a data model. So the data model, first of all, is a graphical representation of a database. So when we say it's a graphical representation, that's inherently what it does is it's easy to share information with a non-technical person. By that I mean a business stakeholder, an end user who does not know technical details about database and does not need to know the technical details about the database. So the data model is a graphical representation of the underlying database, and we use this graphical representation, this graphical tool, to sort of share our design and get approved our design from the business stakeholders or whoever is the champion of whoever has requested that project. So it's the business people who look at that data model and say, oh, this is, and you explain to them what this model is doing, how the data is flowing from one entity to another, or how the data is flowing throughout the organization. And that's what a business stakeholder or the end user signs off on. And then the application programmer or the database analyst can move to the next step. The other, which is a very important function of data models, is somebody, let's say for example, you work in Diebold and you have this database to enter employee training. So somebody designed that database 5-10 years back, and you have been using the database. Everything works perfectly, everything's going fine, but then your HR says that we need to gather more information in this system. We need to add some more data or records we need to collect in this database. So now the application programmer or you as the database analyst, it's your job. Go ahead and make changes to this database so that it can fulfill this new requirements. How do you do that? The database was created 5-10 years back by somebody who, let's say, doesn't even work in the company anymore. We don't even know if we make one change in one table, that's a student table, what all other entities or tables it impacts, what other application it impacts. So the first starting point for a database analyst is that he or she will say, can you please give me the data model, the design of this database, so that I can scale it, I can change it, I can edit it, or I can add to it, and I can see what are the impacts of my change. So that's again a very important need of data model, is so that when somebody else is working on that database, trying to change it, edit it, their first starting point is to look at the data model. Then the third person who really use it, a data analyst, not a database analyst, a data analyst, or somebody who creates reports, or maybe a non-technical person who is creating reports. So he said, I want to create a sales report including our customers, their buying preferences, what kind of things they buy in summer, the products they're buying, what are the characteristics of it, things like that. So multiple things I want to include in my report, my sales report, or my customer buying habits in summer. So before that person can create a report or even ask somebody to create the report, he or she need to know what kind of data is available, what has been collected in the database, what are we storing, And so he can, so then he or she can request that these are the fields I want. So for example, they need to know whether are we collecting our customers, how much money they make, what zip code they live in, how many cars they drive, things like that. So how do we get answers to these questions? Again, you look at the data model, which lists everything which is there in your database. So you read that, and then either you can use some basic SQL, or you can put a request with your technical department that I want you to pull data on all these fields which I saw from the database design of the data model. Okay. And I know it's kind of an abstract concept, this data model. What is this data model? It will be quite clear to you by the end of this chapter, or this chapter plus the practice questions I have for you. And then that concept would again be sort of re-emphasized or refreshed, or you will sort of apply it in the assignment for related to this chapter. Okay, so the data modeling is done by ER models, or entity relationship modeling. E stands for entities, R stands for the relationship between those entities, and attributes are characteristics of that entity or that relationship. So for example, and I'm going to repeat this again later more detail, but just for example, in a university database, what would be an entity? Student, faculty. What is the relationship between them? A student has many faculty, and as teachers in multiple classes, things like that. And what are the characteristics of a student entity? First name, last name, address, city, zip code, state, specialization, GPA, fees due, things like that. So these three are the building blocks of excuse me, entity relationship model. Entities, those are, you can think of the containers about which we are collecting data. So that's sort of a one big container. What data are we collecting about this container? Like student, faculty, course. Those are called attributes. And then since in a database we have multiple entities, and as I have mentioned earlier before, that the strength of a database is that you can connect multiple tables, and right now which we are calling entities at the modeling stage, that the strength of the database is that these entities are connected to each other, unlike multiple spreadsheets, Excel files, which are not. So when we connect those entities together, they are connected via relationship among them. So those are the three building blocks of entity relationship modeling or diagram. Okay, so let's start first with what is a entity. So think of, you are given a domain, or you are given a project. Develop a database for a university, or develop a database for a company, develop a database for a store, develop a database for Amazon or a retailer. So in each this domain, you have entities about which you want to collect the data. So let's start first with a company. In a company, you want to collect you want to collect data about its employees, right? In a university, you will collect data about students, maybe faculty, buildings, courses. These all are, and employees as well. These all are entities in a university database. Hospital, patient, physicians, what else would be? Number of rooms, buildings, things like that. So all these are example of entities. So entities can be persons, places, objects, events. the easiest way to think is that if something is a noun, it can be an entity, unlike an action, which cannot be an entity. So how do we create a entity? That's how an entity looks like. Let me go to this one first. So entities are the way we represent. You can think of it as a things about which we are collecting data about. So entity has, of course, the name of the entity, a primary key, and a attribute. So let me give you an example of entity. Let me open something. Okay. Okay. Let's see. Okay. So how do we draw an entity? Entities are represented by sort of this rectangle shape thing. Oops. And put a box here. On this top box goes the name of the entity, student, patient, employee, building, lab, whatever you are collecting the data on. So let's say student. So that's the name of the entity. And then next you list its attributes about what you are collecting the data on. We will get to attributes and primary key in a minute after I've gone through my slides, so city and stuff. So these are sort of the examples of attributes which comes inside the entity. So that's the diagram for entity. So that's how you create a entity. Name on the top, primary key, and attributes. We will get more into detail about attributes in a minute, and primary key. So an easy way to remember what can be an entity is any object about which has multiple instances. That means you have multiple records and what it should not be, entity should not be, is a user of the database or an output. So what do I mean by this? Let's say if you look at the top entity, there are two things which are been happening here which is incorrect. The treasurer is an user of the system. So your question might be, well, a student, a patient, employee are also user of the system. Yes, they are. But a key thing to remember is, are there more than one employee in a company? Yes. More than one patient? Yes. More than one student? Yes. So then we collect data about that. Here the treasurer is a single user. Something like, let's say you are doing creating a database for a company, and you create an entity called employee, which is correct, but then you create an entity called CEO, because CEO is a very important person in the company. But again, how many records or instance of CEO are there? One. So that's a wrong entity. You cannot create an entity for a single system user. Got to have multiple instances or records of that. Same thing here, expense report. That's expense report are, or any kind of reports are, the output of our database. So the whole purpose of creating a database is that I pull some records from here, some records from here, and in a database they all are connected, have relation with each other. Remember the definition, logically related data, so they are related to each other. So what that means is that I can combine or I can pull data based on their relationship with each other, and I am the one who's creating the report. So you don't have to create a entities for reports, because reports are the output of the system. The reports are the reason why we are creating this database, so that then once this database has the data in a logical fashion, we can manipulate it, summarize it, consolidate it based on our reports. And again, a thing to remember our reports is reports changes every second day. So reports are different. Their needs for reports are different. So if you create an entity that sort of is in a fixed format, so we want to manipulate, we want to create different reports, and those are the output of a database system. And again, these things will become a little bit more clearer as we do some of the questions, as you do the entity relationship diagrams. So now we understood what an entity is. Now let's talk about attributes. So there are various kinds of attributes in an entity. So remember when I showed you this in my very poorly done my handwriting. Well, it's not my fault. It's this tool here. Okay, so these are all attributes. So let's look at their properties. So there are required versus optional attribute. So I'm collecting data about students. What would be the required? What I need to collect data from students? Their name, of course. Their name, their address, zip code, social security number. So anything I really need to collect, I really need to have in my database, I will make those attributes as required for that entity. What would be optional? Let's say I'm collecting data on students, so name, all those things which I just mentioned. Then you are collecting data on their phone, cell phone, home phone, office phone. How many of us have home phone anymore? I do not, from maybe last 5 years. So if you make home phone as a required field, so the user or whoever is the data entry person will say, okay, home phone, and the student will say, I don't have one, blank. The system will give an error. No, this is a required field. So again, so we cannot make something like that as required. So something like home phone, I will make optional. So that means you can skip that data entry into that field because it's optional. Something like if you're doing a survey of potential customers, you ask them what your name is, you're standing outside the mall doing a survey, and then that result of the survey will be entered in a database. So you say your name, your preference, how often do you come to mall, how often do you buy from Amazon, and can you tell me how much money you make? Not everybody is going to tell you that. So again, in your database, you will make that field as optional because a lot of time it will be left blank. That's your required versus optional. Next is simple versus composite. So a simple attribute would be something like, let me start from this side. A composite attribute would be something like, let me get a better pen. Something like name, which is made up of multiple values, because name has first name, middle name, last name. So name could be further broken down into first name, middle initials, and last name. So if you just list name in your entity, that means you are using it as a composite attribute, just so that it's a technical term just to understand it. We do not want composite attributes. We want them to be broken into simple attributes. Same thing with address. So instead of using composite attributes like name or address, we like to use simple attributes like first name, last name, street address, zip code, street address, city, zip code, state. The reason for that is for our preference for simple attribute is if at the, sorry, let me rephrase that, at the entity relationship diagram stage, which is the starting point of creating your database, you are allowed to have composite attributes like name or address, but then the next stage of that is called normalization, which is your chapter number 5. At that stage, you have to follow an additional step of something called normalization, which will ask you to break all those composite attributes into simple ones. So either you do this work right now, or you have to go through that normalization process. What I like to do is, what my preference is, that I will do the hard work right at the beginning, the main work. So that way, when we will be done with our entity relationship diagram, we can completely skip the next process or the next step called normalization, chapter number 5, which you will learn in chapter number 5. So I would recommend that even right at the entity relationship diagram stage, even though we are allowed to have attributes like name and address, I would suggest let's break them into simple attributes and start writing first name, last name, and address should be street address, city, state, zip code, and things like that, so that we don't have to do that additional step later. Next is single valued versus multi-valued attribute. I'm entering data about my employees or employee, and I say, okay, name, address, what all skills do you know? So you say, okay, my skills are, I know SQL, I know business intelligence, I know project management, I know MIS reports, I know Java, I know conflict resolution. So multiple skills. In your database, the attributes cannot be like, when you're doing the data entry, you cannot say, okay, the first attribute is this person knows Java, a programming language, comma, second skill, and so on and so on. Just like you cannot write your first name, comma, last name. All the data entered is single word or a single value. So multi-valued attributes means that we have to again break them. We have to change our design a little bit. Whichever attribute is multi-valued attributes, like skill or degrees you have earned. So let's say undergraduate and MBA. Then you have something called stored versus derived attributes. So again, let's say example, I'm entering information about students or patient or employee, and then I ask them, okay, what is your age, or sorry, what is your date of birth? So for example, let's say they say their date of birth is 1st January 1976, 1/1/1976. So I know their date of birth. Now I don't really need to store their age also in my entity, because if I already have let's say employee, and I have their name and all those things. If I already know their date of birth as an attribute, I really don't need to also have an attribute called age. Why? Because once I have their date of birth, when I'm creating my reports, at that time I can simply say, what is today's date? From today's date minus this person's date of birth, tell me that answer, this calculation in years. You can write a code, small code for this, and I'll get person's age. So that age is an derived attribute. It can be something calculated. Or for example, where did it go? For example, if this is a patient entity, and I know your weight and I know your height. Using these two attributes, I can calculate your BMI. So I really don't need to have an attribute called BMI, because using these two attributes, this can be calculated at the report creation time using the facilities, the coding, the calculation capabilities of a report making tool. So we don't really need to have attributes like BMI or age. Another reason for having this less attributes is because we want to store data in the most logical, efficient, and the lightest possible way, so that our database runs faster. When we pull the data out, it comes out faster, and the answers to our queries are faster. So our goal is to create a logical, light database. Then we have something called identifier attributes or keys. So what is that? So let me give you an example. Let's say we are an airport system or a flight system, and we work for United Airlines, and we are tracking flights which goes from Cleveland to Chicago, United flight, right? So those flights goes morning UA01 and I'm trying to follow a rule where I'm trying to limit each lecture to 30 minutes, especially the technical lecture, so that you can stop at that point and come back. So I'm going to stop this lecture at 30 minutes, as this is just 1 point left here, so that you at one stretch you have we are watching only a 30 minutes lecture. So I'm going to stop this lecture, and the next lecture will start right from this point. Or let me at least finish this, so we have this whole slide finished. Okay, so this example, so we have a flight from Cleveland to Chicago, UA01 at morning 10 o'clock. Then we have this another flight from Cleveland to Chicago at noon. Then another flight to Chicago at 5 p.m. So 3 flights going from Cleveland to Chicago, one at 10, one at noon, and one at 5 p.m. The way it works is all those flights will have the same number, because they all are between two same cities. So they all may be called UA07. So they all have the same flight number, UA07. Okay. So when we have this flight called UA07, which is repeated 3 times in a day, then it will become very difficult to differentiate between those 3 records. So we will be entering a record starting with flight number UA07 for 10 o'clock time, one again for 12 and 5. So it will become very difficult for us to differentiate between these 3 records, because just looking at this one field called UA7, that flight number, we cannot differentiate between 2 records because they all have the same flight number. So what should we do here when one field does not help us to differentiate between 2 records? So we will need a second record called the date and the time of the flight. So when I look at these 2 records together, UA01 plus, you don't write plus here, I'm just for the sake of example, UA01 plus today's date 10 a.m. That's a unique record. UA01 today's date noon. UA07 today's date 5 p.m. unique. Then again moving for tomorrow, US01 tomorrow 10 o'clock, US01 tomorrow to noon. So that way, when we are using these two fields together, we have created something that can be used to uniquely identify a record or instance. Now, why is that important to uniquely identify each record instance? It has to do something with a primary key. What is that primary key? That we will start in the next lecture.